Welcome to the chapter on application security principles and threat modeling. This chapter is the foundation of the entire training path that will turn you into a cybersecurity and DevSecOps professional. Before you learn how to attack applications, defend them, or automate their security in a delivery pipeline, you must first understand how attackers think, how risks are evaluated, and how security is built into software from the very beginning. This is exactly what this chapter delivers. Why start with principles and threat modeling? Because security is not a tool you add at the end, it is a way of thinking that guides every decision. Many beginners believe cybersecurity is only about running scanners and finding bugs. In reality, the most valuable skill is the ability to look at an application and ask the right questions. What are we protecting? Who might want to attack it? How could they attack it? What happens if they succeed? These questions form the core of threat modeling, and mastering them early will make every later chapter easier to understand. Let us clarify the vocabulary you will use throughout this training. An asset is something of value that must be protected. Examples include customer personal data, passwords, payment card numbers, intellectual property, and the availability of the service itself. A threat is a potential event that could harm an asset. For example, a criminal stealing a database of passwords is a threat. A threat actor is the person or group behind a threat. Examples include external attackers, malicious insiders, competitors, or automated bots. A vulnerability is a weakness in the application that a threat could exploit. For example, a login form that does not limit the number of password attempts is a vulnerability. An exploit is the concrete technique or code used to take advantage of a vulnerability. A risk is the combination of the likelihood that a threat exploits a vulnerability and the impact if it succeeds. Risk is what allows you to prioritize your work. Understanding these terms precisely is essential because they are often confused. A vulnerability is not a risk by itself. A risk exists only when a threat can reach a vulnerability and cause damage. This distinction is central to prioritizing tests and corrections, which is one of your core professional goals. This chapter introduces the fundamental security principles that guide secure software design. You should memorize these principles because they appear constantly in professional work. Confidentiality means that information is accessible only to those who are authorized to see it. Encryption and access control protect confidentiality. Integrity means that information cannot be modified in an unauthorized or undetected way. Digital signatures and checksums protect integrity. Availability means that the service and its data remain accessible when needed. Protection against denial of service attacks supports availability. These three properties are known together as the classic security triad. Every security control you will study exists to protect one or more of these three properties. Beyond the triad, you will learn defensive design principles that reduce risk before any code is written. Defense in depth means using multiple independent layers of protection, so that if one layer fails, others still protect the asset. For example, an application may use a firewall, input validation, and database permissions together. Least privilege means giving each user, process, or component only the permissions strictly needed to do its job, and nothing more. A web server that only reads files should not have permission to delete them. Fail securely means that when something goes wrong, the system should default to a safe and closed state rather than an open one. For example, if an authorization check crashes, access should be denied, not granted. Minimize the attack surface means reducing the number of entry points an attacker can target. Disabling unused features, closing unused network ports, and removing unnecessary accounts all shrink the attack surface. Never trust user input means treating all data coming from outside the application as potentially malicious until it has been validated. Threat modeling is the structured process of applying these principles to a specific application. In this chapter you will be introduced to the general workflow, which you will practice in later activities. The typical steps are: describe the system and its data flows, identify the assets, identify possible threats, rank the risks, and decide on countermeasures. A widely used method to identify threats is called STRIDE, which is a memory aid covering 6 categories of threat: spoofing, pretending to be someone else, tampering, altering data, repudiation, denying an action was performed, information disclosure, leaking data, denial of service, making the service unavailable, and elevation of privilege, gaining higher rights than allowed. You will also encounter the idea of a data flow diagram, which is a simple drawing showing how data moves between users, servers, and databases, and where trust boundaries exist. A trust boundary is a line where the level of trust changes, for example between the public internet and your internal server. To make risks comparable, professionals use scoring systems. You will be introduced to the idea of rating each risk by likelihood and impact, often on a simple scale such as low, medium, and high. A vulnerability that is easy to exploit and causes severe damage is high risk and must be fixed first. A vulnerability that is difficult to exploit and causes little damage is low risk and can wait. This prioritization is what separates a professional approach from random bug hunting. This chapter also connects to the broader DevSecOps philosophy that runs through the whole course. DevSecOps means integrating security into every stage of software development and delivery, rather than treating it as a final checkpoint. The principle of shifting security left means addressing security as early as possible, ideally during design and coding, because problems found early are far cheaper and faster to fix than problems found in production. Threat modeling is one of the earliest and most powerful shift left activities. By the end of this chapter, you should be able to speak the language of application security fluently, understand the difference between threats, vulnerabilities, and risks, apply the core security principles, and understand the purpose and basic steps of threat modeling. These skills prepare you directly for the practical chapters that follow, where you will conduct penetration tests, identify real vulnerabilities such as injection flaws and broken access control, fix them properly, and build a secure delivery chain using automated security testing. Take your time with the definitions in this chapter. They are simple but precise, and everything you build later depends on them. Read carefully, because the multiple-choice quiz that follows will test your understanding of these terms, principles, and the logic of threat modeling.